Imagine a world where tasks that once demanded hours of human effort unfold with the steady precision of machines, their gears turning tirelessly and without pause. This vision, so familiar to us today, was once the stuff of dreams and anxieties gradually taking shape over centuries. To understand the future of automation, we must first trace its roots, a journey that stretches from ancient water wheels to the intelligent systems of the digital age. Long before the Industrial Revolution, early civilizations sought ways to ease the burden of manual labor. Evidence shows that as early as the 1st century before the Common Era, people harnessed the power of water wheels to grind grain and irrigate fields, while windmills of the 9th century captured breezes to perform similar work. These simple machines were among the earliest attempts to automate repetitive tasks, driven by the desire for efficiency and consistency. Over the centuries, the quest for mechanization gained momentum. In the 16th century, William Lee's mechanized stocking loom offered a glimpse of the future, a device capable of knitting stockings far faster than human hands. Yet, this innovation was met with unease. Queen Elizabeth I hesitated to grant Lee a patent, fearing such machines would displace her subjects and cause social unrest. Her concerns proved prescient. As mechanization spread, it sparked resistance. In the 19th century, textile workers and artisans, threatened by the relentless advance of machines, staged riots to protest their loss of livelihood. Mechanization, it seemed, was both a promise and a peril. The dawn of the Industrial Revolution, between 1790 and 1840, marked a watershed moment in automation's story. This era witnessed seismic changes in how work was organized and performed. James Watt's improvements to the steam engine in 1765 unlocked new possibilities, powering factories that could operate on an unprecedented scale. Water-powered mills became the beating heart of industrial towns, and the shift from handcrafted goods to machine-aided production transformed entire economies. By 1785, Oliver Evans had created an automated flour mill, where a series of interconnected machines performed tasks once handled by teams of millers. This period was defined by what historians often call self-acting machines, devices powered by steam or, later, electricity, capable of operating with minimal human intervention. The Jacquard loom, introduced in 1801, stands as a landmark achievement. By using punch cards to control weaving patterns, the loom could produce intricate textiles automatically and is now recognized as the first programmable machine. The influence of the Jacquard loom would echo into the future, especially in the development of early computers. Charles Babbage's difference engine, an ambitious 19th century project, drew direct inspiration from such mechanical marvels, laying the groundwork for the computational revolution to come. The 19th and early 20th centuries saw automation advance steadily. The electrification of factories brought new efficiencies, with electric motors replacing steam power and enabling more flexible manufacturing layouts. In 1913, Henry Ford unveiled the moving assembly line. For the first time, cars could be produced at scale, each worker performing a specialized task as the product moved along the line. This innovation not only revolutionized automobile manufacturing, but also became a model for mass production across countless industries. World War II accelerated these trends. The demands of military manufacturing led to further automation, with nations racing to produce armaments and supplies at scale. In the aftermath, Japanese manufacturers pioneered new approaches, refining automation with a focus on quality and efficiency, a legacy that would shape global industry for decades. The seeds of modern automation were sown in the post-war era. The late 1940s and 1950s saw the advent of electronic computers and the first true industrial robots. In 1949, William Gray Walter built autonomous robots that could navigate their environment, a precursor to more complex machines. The term robot itself entered the lexicon in 1921 thanks to Carol Sapek's play, though it would take decades before robots became a practical reality. In 1961, the Unimate robotic arm was installed in a General Motors factory, marking the beginning of robotics in industrial settings. The digital revolution that followed brought new layers of automation. The 1960s and 1970s introduced programmable logic controllers, PLCs and computer numerical control (CNC) machines, enabling unprecedented precision and flexibility in manufacturing. Tools like computer-aided design (CAD) and computer-aided manufacturing (CAM) reshaped how products were created. The 1980s and 1990s saw computers permeate every aspect of industry, automating not just physical tasks but also the flow of information. Amid these advances, the principles guiding automation became more clearly defined. At their core, these principles emphasize automating specific tasks rather than entire jobs. This distinction matters. While machines might perform repetitive or hazardous duties, humans often shift to roles requiring judgment, creativity, or oversight. Automation redefines roles and processes, impacting both high and low-skill positions. Foundational concepts such as visibility, accuracy, simplicity, efficiency, speed, and experience have emerged as guiding stars for those who design automated systems. For organizations, managing by exception, eliminating unnecessary manual procedures, and integrating data sources are recognized strategies for maximizing the benefits of automation. The quest to imbue machines with intelligence, what we now call artificial intelligence, can be traced to the mid-20th century. Alan Turing in the 1950s famously pondered whether machines could think, proposing what became known as the Turing test to measure a machine's ability to exhibit intelligent behavior. The 1956 Dartmouth Conference marked the formal birth of artificial intelligence as a field of study, setting the stage for decades of research and discovery. Today's automation, powered by digital technologies and AI, is the product of this long evolution. It builds upon centuries of innovation, from water wheels and windmills to programmable looms and robotic arms. Each milestone, whether the Jacquard looms punch cards or Ford's assembly line, has contributed to a world where machines not only perform tasks but also learn, adapt, and collaborate with humans. While the future of automation remains unwritten, its foundations are firmly anchored in this rich history. The journey from mechanization to modern AI is not merely a tale of machines, but of human ingenuity, the ongoing effort to shape tools that extend our capabilities, redefine our work, and transform society itself. As we look ahead, understanding these foundations helps us appreciate both the promise and the challenges that lie on automation's horizon. Every day, factories, hospitals, warehouses, and offices pulse with the steady, relentless rhythm of automation. The world has entered an era where robots and algorithms are not just tools, they are active collaborators, reshaping industries and redefining what is possible. This transformation is vast, evident not only in the flicker of LED lights on factory lines, but also in the silent calculations of artificial intelligence guiding clinical decisions and orchestrating the flow of goods across continents. Nowhere is this shift more pronounced than in manufacturing, long the proving ground for new waves of automation. In 2024, 542,076 industrial robots were installed globally, raising the world's operational stock to 4.7 million units. The leaders in robot density, China, Japan, the United States, Korea, and Germany, are setting the pace, especially in the automotive and electronic sectors. These industries are undergoing a profound transformation driven by economic pressures and the need to stay competitive. As 2026 approaches, manufacturers face rising costs and supply chain uncertainties, but many are responding with significant investments in automation technologies. This trend goes beyond simply installing more robots. It is about building digital ecosystems where machines, sensors, and software work seamlessly together. Today's manufacturing floor is a hive of interconnected processes. Digitalization lies at the heart of this change, enabling real-time data collection and analysis. Artificial intelligence now plays a crucial role in both routine production and complex decision-making. Data-driven manufacturing allows firms to predict equipment failures before they occur, optimize production schedules, and continually improve quality. Robotics, once limited to repetitive tasks, are now increasingly agile, capable of switching between product lines and adapting to new challenges with minimal human intervention. Sector outlooks point toward modular and flexible manufacturing systems, especially as the automotive industry pivots to electric vehicles. These adaptable systems enable rapid retooling and smaller, more customized production runs, reinforcing automation's role as a cornerstone of modern manufacturing. Healthcare is also experiencing an automation revolution. The integration of robotics and artificial intelligence is transforming not just how care is delivered, but how it is conceived. Robots now assist in surgeries, perform logistics tasks, and even conduct routine checkups. In the operating room, robotic systems offer precision beyond the capabilities of the human hand, resulting in less invasive procedures, quicker recoveries, and improved patient outcomes. The benefits extend beyond surgery. Hospitals deploy robots to deliver medications, transport supplies, and support clinical staff, all contributing to greater efficiency and better patient care. The market for medical robotics is expanding rapidly, with projections indicating growth from $16.6 billion in 2023 to $63.8 billion by 2032. This surge is fueled by a wide range of applications: diagnostics, surgery, logistics, and more. artificial intelligence amplifies these benefits, enabling personalized treatment planning and supporting clinicians in making more informed decisions. Hospitals that adopt these technologies often gain a competitive edge, improving both sustainability and efficiency. However, the promise of automation in healthcare brings new challenges. Integrating advanced robotics and artificial intelligence requires substantial investment, careful change management, and ongoing workforce development. The relationships between clinicians and intelligence systems are complex, demanding new approaches to training and collaboration. Still, the evidence points to a future where the partnership between human expertise and machine intelligence is central to delivering high-quality, efficient care. If healthcare and manufacturing are the twin pillars of automation's current landscape, logistics serves as the nervous system connecting the global economy. The flow of goods, once managed by manual processes and static schedules, is now increasingly orchestrated by digital twins, virtual models that mirror and predict the behavior of entire supply chains. Here, automation is about more than moving boxes. It is about visibility, adaptability, and speed. Artificial intelligence uses machine learning to optimize pricing, routing, and supply chain decisions in real time, often surpassing even the most experienced human planners. Robotics are at the core of this transformation in logistics. Autonomous systems now pick, pack, sort, and deliver goods with a level of precision and speed that was once unimaginable. Specialized robots such as SCARA models are valued for their ability to handle intricate tasks at high velocity. The integration of the Internet of Things, artificial intelligence, and blockchain technologies further enhances real-time tracking, inventory management, and end-to-end supply chain visibility. For organizations, the result is not only lower costs and faster delivery, but also the ability to respond dynamically to disruptions and opportunities alike. Automation's influence extends beyond the physical movement of goods or the direct provision of care. In the world of services, process automation is quietly but profoundly changing how work gets done. From back-office operations to customer service, organizations are using software robots to streamline tasks, reduce errors, and allocate resources more effectively. Robotic process automation is now a market projected to surpass $30.85 billion by 2030, driven by success stories in manufacturing, invoice processing, bank reconciliations, and countless other administrative functions. The benefits are clear: cost savings, shorter project timelines, and greater customer retention. Yet, the rise of automation in service industries is not without friction. Workers face new pressures as routine tasks disappear and the demand for specialized, tech-savvy roles grows. Some positions see wage increases as they become more complex and integral to automated workflows, while others experience declines as traditional functions are absorbed by machines or software. Evidence suggests, however, that automation often creates as many jobs as it eliminates, especially for those who collaborate effectively with these new systems. Productivity gains are greatest where humans and machines work side by side, each complementing the other's strengths. The impacts of automation are nuanced. Exposure to automation does not always mean job loss. In many cases, it leads to a redefinition of expertise. Workers who adapt and develop new skills often move into higher value roles, while organizations benefit from improved efficiency, scalability, and accuracy. Case studies from manufacturing, healthcare, and agriculture show that automation can even promote workforce diversity and create new opportunities for underrepresented groups. As of 2024, approximately 78% of organizations have deployed some form of artificial intelligence, reporting tangible gains in speed, cost reduction, and accuracy. The majority of manufacturers are engaged in digital transformation initiatives, incorporating industrial artificial intelligence, the industrial Internet of Things, and edge computing into their operations. These technologies are not only changing how products are made and delivered, they are reshaping the very fabric of work, demanding new patterns of collaboration, governance, and skill development. The future of automation is not a distant prospect, but a present reality unfolding across industries. It is a story of relentless innovation, tempered by the need for thoughtful adaptation. Organizations that harness these technologies wisely are poised to thrive, while those that hesitate risk falling behind. The challenge, as always, is to balance the promise of greater efficiency and precision with the human need for meaningful work and social cohesion. In this new landscape, automation is not just a tool, it is a partner, shaping the world alongside us. Peering into the future of automation is like watching a city skyline rise, one tower at a time. Each new addition changes the view and hints at possibilities yet to come. The landscape taking shape today is defined by technologies and trends that promise more than simply accelerating what machines already do well. Instead, they invite us to imagine new forms of collaboration, creativity, and ethical responsibility, all woven into the fabric of intelligent systems. The horizon is crowded with innovations, but a few stand out for their transformative potential. Among the most striking developments is the rise of collaborative robots, often called cobots, and their increasingly sophisticated humanoid counterparts. Unlike their industrial predecessors, which were separated from people for safety, these new robots work side by side with humans, reshaping how workplaces function. They are not just about replacing repetitive labor, they enhance productivity and foster genuine human-robot collaboration. The appeal is clear. Cobots can be installed quickly, require minimal training, and cost less than traditional automation. This has opened the door for smaller manufacturers and businesses to access automation's benefits, allowing even small and medium-sized enterprises to gain flexibility and support their workforce in entirely new ways. But the story is not just about the robots themselves. The intelligence driving them is evolving rapidly, fueled by advances in industrial artificial intelligence and, increasingly, generative artificial intelligence. Where once a robot could only follow a fixed script, now it can adapt, learn, and even anticipate needs. Predictive maintenance is becoming commonplace, enabled by real-time data from connected devices. These intelligent systems can sense when a part is likely to fail, schedule repairs, and minimize downtime changes that ripple across entire industries, saving resources and reducing waste. Another emerging trend is the appearance of mobile manipulators and new market entrants. These systems are not fixed to a single location. They roam factory floors, warehouses, and even public spaces, performing tasks that once required a fleet of specialized machines. This mobility, combined with increasingly versatile arms and tools, allows for greater adaptability and efficiency, especially as industries face ever-changing demands. The move towards software-defined automation is also reshaping how we think about machines. Rather than being limited by hardware, future systems will be defined by software that can be updated and reconfigured as needs change. This flexibility is only possible with robust data connectivity. In fact, data connectivity is quickly becoming the cornerstone of modern automation. Unified data environments enable not just real-time analytics, but also the seamless flow of information across entire organizations. This creates the foundation for predictive maintenance, smarter decision-making, and, ultimately, more autonomous operations. Connectivity, in turn, is unlocking the power of the cloud. By integrating artificial intelligence, machine learning, and cloud computing, businesses are transforming how they operate. Intelligent automation is no longer limited to simple rules. It now combines artificial intelligence, machine learning, and robotic process automation to handle complex workflows and business processes. The majority of organizations recognize this potential. Approximately 88% are planning projects that embrace intelligent automation, though many acknowledge that data quality remains a critical factor for success. Agentic artificial intelligence and autonomous agents are also on the rise. These systems do not just follow instructions, they act with a degree of autonomy, making decisions and managing tasks on behalf of humans. Combined with advances in business process management and semantic software, they are enabling a new generation of automation that can adapt to changing circumstances and even augment human intelligence. This shift is not just about efficiency. Increasingly, automation is moving from a model of replacement to one of augmentation. As intelligent systems take on routine tasks, human skills like judgment, creativity, and critical thinking become more valuable. Rather than displacing workers, many automation projects now focus on amplifying what people do best, enabling a hybrid economy where humans and machines create new forms of value together. Of course, none of this is possible without the seamless merging of operational technology and information technology. This convergence unlocks the potential of artificial intelligence and big data, creating systems that are not just automated but truly intelligent. With this comes a new set of challenges, especially around the responsible use of data and the security of operational systems. As automation becomes more deeply embedded in the fabric of business and society, the importance of robust cybersecurity and unified data environments only grows. Yet, as automation systems grow more capable and independent, questions of ethics and responsibility come sharply into focus. The use of artificial intelligence raises concerns about bias and accountability. Without proper oversight, automated decision-making can perpetuate or even amplify existing inequalities. Recognizing these risks, global organizations like United Nations Educational, Scientific, and Cultural Organization have established standards for artificial intelligence ethics, emphasizing transparency, fairness, and human oversight. Leading universities have echoed these concerns, highlighting the dangers of bias, lack of accountability, and the broader societal risks that come with unchecked automation. Sustainability is another critical consideration. As artificial intelligence and automation systems become more powerful, their energy demands can rise sharply. There is growing recognition of the need for sustainable and ethical practices, including responsible management of computational resources. This means designing systems that are not just effective but also energy efficient and mindful of their environmental impact. Behind all these advances is a recognition that the future of automation is not predetermined. Each breakthrough brings new opportunities and new responsibilities. The merging of digital transformation, data connectivity, and intelligent automation is already reshaping industries in ways that would have seemed unthinkable a generation ago. But the path forward will be guided as much by our choices about ethics, sustainability, and human purpose as by the relentless advance of technology itself. As we look ahead, the most exciting prospect may not be the machines themselves, but the new forms of collaboration they make possible. In the emerging human-machine hybrid economy, value is created not just by what machines can do, but by how people and intelligent systems work together. The story of automation is still unfolding, and its next chapters will be written not only in code and silicon, but in the choices we make about the future we want to build. The future of automation is not just a story of technology. It is, at its core, a deeply human saga. As intelligent machines and automated systems become woven into the fabric of daily life, their influence extends far beyond the factory floor or the back office. The way we work, learn, and relate to one another is being quietly yet inexorably transformed. In this chapter, we focus on the societal impacts of automation, how it shapes employment, education, and the social order, and the choices we face as a global community. The most immediate and visible effect of automation is its impact on the workforce. Across industries, from manufacturing to logistics and clerical work, automated systems are taking over tasks that once required the hands and minds of millions. Some jobs are disappearing entirely, while many more are being reshaped, with certain tasks automated and others reserved for human judgment and creativity. By 2035, it is estimated that nearly 4 in 10 employee skill sets will be transformed, not just through job loss or creation, but because the very nature of work is changing. Sectors with high exposure to automation, such as manufacturing, logistics, and office administration, are experiencing profound shifts in the demands placed on workers. The result is not uniform displacement, but rather an uneven patchwork, with some groups and regions feeling the impact more acutely than others. For those whose roles are most at risk, the need for retraining is urgent. Automation often affects different demographic groups unevenly, with less educated workers typically bearing the brunt. Research shows that over half of the growth in wage inequality since 1980 can be traced to the forces of automation, particularly as routine and repetitive tasks are handed over to machines. This process does not simply eliminate jobs, it changes the skills needed to succeed. As automation progresses, there is a growing premium not only on technical expertise, but also on a range of human abilities that machines cannot easily replicate. Social and emotional intelligence, clear communication, leadership, and adaptability are becoming the new currency of the workplace. These are the very qualities that enable people to collaborate, solve problems creatively, and navigate the unpredictable traits that remain beyond the reach of even the most advanced algorithms. Yet, even as old roles disappear, new opportunities are emerging. Entirely new occupations and career pathways are arising alongside automation, offering alternative routes to prosperity for those able to seize them. The growth of advanced manufacturing, for example, has created a demand for talent with specialized technical skills, often outpacing the available supply. Reports highlight persistent talent shortages and mismatches between the skills employers seek and those job seekers possess. This gap is especially pronounced in fields requiring expertise in robotics, machine learning, and systems integration, as well as in positions that blend technical competence with strong interpersonal skills. Adapting to this evolving landscape is not simply an individual responsibility, it is a collective challenge. Lifelong learning is becoming a central principle of workforce policy, with calls for agile, inclusive support systems to help people navigate technological disruption. Practical strategies for adaptation include transparent communication about changes, involving employees in the process, and providing accessible training and familiarization programs. Upskilling equipping workers with the abilities needed for emerging technologies is essential if society is to bridge talent gaps and ensure that the benefits of automation are more broadly shared. Education, too, is undergoing transformation in the age of automation. Intelligent systems are beginning to streamline administrative tasks, personalize learning experiences, and support teachers in new ways. Automation in education promises greater efficiency, with faster grading, tailored lesson plans, and the potential to reduce teacher burnout by easing administrative burdens. As curricula and teaching methods evolve, personalized learning guided by data and adaptive algorithms offers students more targeted support, helping them master material at their own pace. The market for artificial intelligence in higher education is projected to grow significantly, reflecting the belief that automation can enhance both student and educator effectiveness. However, these advances bring their own challenges. The same forces that enable personalized learning and greater efficiency also raise questions about fairness, equity, and the broader purpose of education. If automation leads to a higher share of college graduates while simultaneously increasing inequality and reducing labor's share of economic output, society must confront how to distribute the rewards of progress. The International Monetary Fund and other organizations warn that, without thoughtful policy, automation could widen the gap between those who benefit from new opportunities and those left behind. Global patterns reflect these concerns. Countries that invest early and deeply in robotics and automation often reap the greatest gains, while others risk being left behind. The benefits of automation are not evenly distributed, and the resulting shifts in labor force composition can intensify global inequality. These realities underscore the need for socially responsible automation, an approach that balances efficiency and innovation with careful attention to social impacts. There is another, less tangible but equally important dimension to consider: the way automation shapes our sense of purpose, dignity, and well-being. Losing a job to a machine is not simply an economic setback. It can be a deeply personal blow, raising fears of dehumanization and loss of meaning. Some research points to increased stress and health impacts for workers facing rapid technological change. At the same time, automation can bring genuine human benefits, reducing stress, improving work-life balance, and freeing people from drudgery. The challenge is to ensure that these gains are widely shared and that the transition is managed in a way that supports human flourishing. Society's attitudes toward automated systems are shaped by concerns about justice, fairness, and the role of human judgment in decision-making. Many people worry about the potential for bias or error in artificial intelligence-driven decisions, and there is broad agreement on the importance of human oversight and accountability. The risks of over-reliance on machines are real, as is the need for rigorous testing and safeguards to prevent inaccuracies or unintended consequences. Ultimately, the integration of automation into daily life is not inevitable, but a process shaped by collective choices. Policy frameworks can help guide adaptation, drawing on lessons from previous episodes of technological change. Strategies that align automation with broader social and business goals, engaging stakeholders, investing in continuous improvement, and measuring outcomes holistically can foster innovation while managing risks. The future of automation holds the promise of prosperity and progress, but only if society takes an active role in shaping its direction. By investing in skills, supporting adaptation, and insisting on fairness and responsibility, we can ensure that intelligent machines remain tools for human advancement rather than agents of division. The story of automation is, above all, a human story, one that will be written not by machines, but by the choices we make together. As the world stands on the brink of a new era shaped by automation, the choices made today will determine whether this technological tide lifts all boats or leaves some stranded. The rapid expansion of artificial intelligence, in particular, demands not just technical agility, but deep reflection on origins, intent, and direction. Understanding where these technologies come from, how they have evolved, and what problems they were designed to solve remains crucial for preparing wisely for what comes next. The future is not written in code alone, but in the values, strategies, and frameworks chosen by those who guide, build, and use these powerful systems. One of the clearest lessons to emerge is the importance of socially responsible automation. This is not a call for utopian ideals, but a pragmatic framework for development that places human well-being, dignity, and shared prosperity at the center. Socially responsible automation means designing and deploying technology with an eye toward not only efficiency and profit, but also inclusion, safety, and sustainability. It is a guiding principle that asks, who benefits from automation, who is at risk, and what can be done to ensure that progress does not come at the expense of the vulnerable. This mindset is increasingly seen as essential for navigating the complex terrain ahead. Looking to history, scenarios for the future of work often draw lessons from past industrial revolutions. The recurring theme is adaptation societies that invested in education, worker protections, and new forms of social support weathered disruptive change more successfully than those that did not. Policy options today echo these lessons, advocating for lifelong learning, an agile workforce, and comprehensive support systems that can buffer shocks and smooth transitions. The goal is not only to cushion the blow of job displacement, but to create pathways for people to thrive alongside intelligent machines. A robust framework for inclusive and sustainable workforce transformation has emerged, structured around 5 core elements: vision, skills, technology, process, and culture. Vision provides direction, ensuring that all efforts are guided by clear, shared objectives. Skills are continually developed and refreshed, not as a one-time fix, but as an ongoing process. Technology is introduced thoughtfully, aligned with organizational and societal goals rather than for its own sake. Processes are re-engineered to leverage both human and machine strengths, while culture nurtures adaptability, open communication, and a sense of shared purpose. Together, these elements help organizations and societies embrace change rather than merely endure it. For businesses, developing a process automation strategy is neither a one-off project nor a simple plug-and-play affair. It begins with a careful assessment, an honest look at existing workflows, pain points, and opportunities. From there, goal setting becomes essential. What does successful automation look like, and how will it serve the organization's broader mission? Stakeholder engagement is key, involving not just executives and engineers, but employees at all levels, customers, and even partners. This inclusive approach helps surface concerns, spot unforeseen risks, and build buy-in. Perhaps most importantly, automation strategy is never static. Continuous improvement and feedback loops ensure that systems evolve as needs and circumstances change. Navigating the complexities of automation also involves aligning these efforts with overall business strategy. This means recognizing and addressing regulatory challenges, as well as the obstacles posed by legacy systems that may not integrate easily with new technologies. Success depends on phased implementation, introducing automation in manageable stages, learning as you go, and refining approaches along the way. User training is not an afterthought but a central component, empowering people to work confidently and creatively with new tools. Ongoing refinement, based on real-world feedback and performance metrics, becomes the engine of long-term resilience and innovation. Some organizations have embraced what is called an everything strategy for automation. This approach revolves around 5 imperatives: simplify, monitor, control, integrate, and measure. By simplifying processes, organizations reduce the risk of errors and make technology more accessible. Monitoring ensures that systems are running as intended and that deviations are caught early. Control maintains security, compliance, and transparency, while integration ensures that automation touches all relevant aspects of the business, not just isolated silos. Measurement closes the loop, providing data-driven insights that fuel further innovation and adaptation. This holistic mindset is increasingly seen as the foundation for building organizations that are both resilient and forward-looking. Adapting to automation is not just a matter for organizations or governments, it is a deeply personal journey for individuals as well. Practical advice centers on engaging actively with change, rather than resisting it or waiting for others to chart the course. Developing transferable skills, abilities that can be applied across different roles, industries, and technologies, provides a buffer against disruption. Investing in new automation skills, from coding to systems thinking to human-machine collaboration, opens doors to emerging opportunities rather than closing them. Upskilling is not a one-time event but a continuous process requiring both curiosity and commitment. Preparing the workforce for emerging technologies involves a portfolio of actions: upskilling, cultivating adaptability, and investing in learning and development. Productivity gains are real and measurable, but so too are the shifts in skills required and the competitive advantages enjoyed by those who embrace change proactively. Organizations that communicate openly about automation, involve staff in the process, and provide ample training and familiarization tend to see smoother transitions and higher morale. Digital upskilling, in particular, has become an ongoing necessity, a process that keeps pace with technology as it continues to evolve. Crucially, the promise of automation is not about replacing people, but about amplifying human potential. The future points toward models of human-artificial intelligence collaboration, where machines handle complexity and repetition, while people provide judgment, creativity, and intuition. Human augmentation using technology to supplement rather than supplant human abilities is emerging as a major trend, offering the potential for societal benefit on a scale not previously possible. This human plus advantage, combining the strengths of artificial intelligence with the unique qualities of human workers, is increasingly seen as the engine of future leadership and innovation. As the economy evolves toward a human-machine hybrid, strategies for leveraging emerging technologies must be balanced with a keen awareness of risks. Rigorous testing and risk management are essential, especially as intelligent automation systems grow more complex and impactful. Security and human oversight remain non-negotiable, providing a backstop against unintended consequences and ensuring that the benefits of automation are broadly shared. The challenge is to find equilibrium balancing efficiency gains with social and economic impacts and ensuring that progress is not achieved at the cost of trust or inclusion. In the end, the strategies that will shape an automated future are those that harness the power of technology while never losing sight of the human story. Automation can drive business growth, boost efficiency, and enhance employee well-being, but only when implemented thoughtfully and responsibly. The road ahead demands continuous learning, collaboration, and vigilance, a commitment not just to technical excellence, but to values and vision that place humanity at the heart of progress. In this way, technology becomes not a force of disruption, but an instrument for building a more innovative, equitable, and resilient world.